Hi everyone. Today I'm going to be talking about greatest common factor of monomials. So here we have two monomials, 9w squared and 3w to the third power. And we're being asked to find the greatest common factor. Okay? So recall a common factor means factors that two things have in common. So, for example, if we have 9 and 6, and I factor them, so 9 factors into 3 times 3, and 6 factors into 3 times 2, their common factor, which also happens to be the greatest common factor between the two, is 3. Okay? But this time we have variables involved as well as numbers. So let's break them down. So let's focus on the number aspect. So let's focus on 9 and 3. So let's look at the factors of 9. In this case, we can break down 9 into 3 times 3. And then we have 3, which is just 3 itself and 1. Okay? And we want to identify the common factors. In this case, it's 3. So between just 9 and 3, it's just 3. Okay, so now let's look at the W component. Okay, so we have W squared. W squared is the same thing as W times W. And W to the third power is the same thing as W times W times W 3 times. Now let's see the factors that they have in common. Well, it looks like they have one W in common, and then they have another W in common. And I think that's it. So our greatest common factor in this case is 3 times W to the second power because there's two of the W's in common. Here's another problem. This time we have 4r to the third power and 10r to the third power. Again, we're going to look at the number component first. So 4 and 10 in this case. 4 can be broken down into 2 times 2. 10 can be broken down into 5 times 2. Now let's identify our common factors. It's just 2 in this case. Our common factor is 2, which also happens to be our greatest common factor. So between 4 and 10, our greatest common factor is 2. Now let's look at the r cubed. R to the third power is the same thing as r times r times r. And you'll notice that we'll have 1, 2, 3 r's in common. So between the r cubed and the r cubed, they have r to the third power in common. And that is our greatest common factor. Here's another problem. This time we have 9b squared and 3. Again, we're going to look at the number component first. So here we have 9 and 3. So let's break down 9. 9 can be broken down into 3 times 3. 3 can be broken down into 3 times 1. And again, our common factor here is just 3, which happens to be our greatest common factor. So I'm going to put a 3 out in front. Alright, the 9b squared has b squared, but the 3 doesn't have any b at all. So do they have any b's in common? No. So we don't put anything for b. So our greatest common factor in this case is just 3. Here's another example. Here we have 7f and 6. Again, we're going to focus on the number component here first. So we have 7 and 6. Well, the only thing that goes into 7 is itself and 1. 6 can be broken down into 3 and 2. And then 3 and 2 can't be broken down anymore, so we'll leave it at that. Do you see any common factors in between here? No. However, do keep in mind that 1 divides into anything, because any number divides 1 is itself. So between 7 and 6, the greatest common factor is just 1. Now we have an F from 7F, but the 6 doesn't have any F's at all. So do they have any F's in common? No. So the greatest common factor between 7F and 6 is 1. Here's another problem. This time we have 5g to the 4th and 14g to the 3rd. Again, we're going to look at the number component first. 5 is just a prime number, so the only thing that divide into it are 5 and 1. 14 can be broken down into 7 and 2. And 7 and 2 can't be broken down anymore, so we'll leave it at that. Do you see any common factors here? No. But we know that 1 goes into both 5 and 14, so I'll write a 1 here for the number part. Now, time to look at g to the 4th. G to the 4th is the same thing as g times g times g times g. G to the 3rd is the same thing as g times g times g. And now let's take a look at the common factors here. We have 1g in common, 2g in common, and 3g in common. So between g to the 4th and g to the 3rd, they have a g to the 3rd in common. And if you've noticed, there's a pattern with finding the greatest common factor with these variables here. The greatest common factor is always going to be, for variables, the smaller number of the exponents. So in this case, we have g to the 3rd and g to the 4th. Okay, and notice that they can only have up to 3 g's in common, because g to the 3rd can only have 3 g's, while g to the 4th has 4 of them. So our final answer is just g to the 3rd. I'm not going to write the 1 because we don't need to. Here's another problem. This time we have 6q to the 4th and 12q to the 3rd. We're going to ignore that negative sign for a minute here. So now let's just take a look at our number components. So we're looking at 6 and 12. Well, we can break 6 down into 3 times 2. 12 we can break into 6 times 2. And the 6 here can be further broken down into 3 and 2. Now let's take a look at our common factors. In this case, they have a 3 in common and they have a 2 in common. So we're going to multiply out our common factors here. In this case, 3 times 2. And that'll give us our greatest common factor, which is 6. So between 6 and 12, our greatest common factor is 6. Now let's look at our variable component, our q's. Q to the 4th is the same thing as q times q times q times q 4 times. Q to the 3rd is the same thing as q times q times q. Well, let's take a look at how many q's we have in common. We have 1, 2, and 3. So for our q's, we have q to the 3rd power, 3 q's in common. Q to the 3rd power. So our final answer is 6q to the 3rd. Now, you might also be thinking, I can break 12 into 4 and 3. Okay, let's do it that way. 4 can be further broken down to 2 times 2. And you'll notice we will still have a 3 in common and 1, 2 in common. And so for a number component, our greatest common factor will still be 6.